All right, here we go. Chapter 5 of the trigonometry final exam review. There we go. All right. This one's all about the identities. Now, I don't have these all written down somewhere. All I do, they're on my wall over there. I don't expect you guys to have these things memorized. I'm going to give you a formula sheet here. Here, let's see if I can pull them up. Unit 5 identities. All right, so this is basically uh, what you guys are going to have on your final exam is this thing. Once Word decides to load here. Nope, that's not it. Might be this one. We'll see. I don't know. Here we go. All right, so here's your unit circle. This is what you guys are going to get. And then below it are all of these identities. All right, so Unit 5 was all about the sum and difference and the double angle and the half angle identities. All right, so these things right here are what we're going to be referencing quite a bit, well, pretty much exclusively in this unit. All right, so here, I'll just throw these right here. All right, so I'm going to come back and forth to these. So first things first, when we're looking at this, they want us to use the sum and difference identities here. If the sine of A is 12 over 13 and the tangent of B is 8 over 15, and B is in quadrant 1. All right, so let's see here. First things first, quadrant 2. We are in quadrant 2. The sine of A, if we make this triangle, the sine is the opposite over the hypotenuse. Using Pythagorean theorem, I'm not going to do that. This is going to be -5. This is a Pythagorean triple. So ideally, you guys have these memorized. If you don't, use Pythagorean theorem. But keep in mind, it is going, this, x-axis is going in the negative direction. So that's a -5. I had a couple of you guys forget that on the quiz or on the test for this unit. And I take off some points for it. So let's just identify the sine of A. That was one that was given to us. The sine of A was equal to 12/13. Right? The cosine of A is equal to -5/13. And then the last one, your tangent. Your tangent of A here is equal to, what do we got here? Opposite over adjacent, so that's 12 over -5. All right, so those are all of your angle A's. Now, the next one is the tangent of B, and that is in quadrant 1. So that's going to be over here. And again, the tangent is opposite over adjacent. Just be very careful when you're setting these things up. And then Pythagorean theorem to get the next one. I actually don't know this one. So we got 15 squared plus 8 squared, plus 8 squared. And it's going to give us something, 289. I think that's 17. Square root of 289 is 17. All right, so our hypotenuse here is 17. All right, so the sine of angle B. Sine of angle B. All right, this is our angle B right here. All right, there's your sine of B. And again, this one here is your A right there. The sine of B is equal to the opposite over hypotenuse, so 8 over 17. The cosine of B is equal to 15 over 17. And the tangent of B is equal to 8 over 15, which was given to us. All right. So that's all the preliminary work that we have to do before we find sine of A minus B, cosine of A minus B, and the tangent of A plus B, right? We have to find these three values. So now, the sine of A minus B, if we look at that identity here, that is the sine of A times the cosine of B. So here, let's do the sine of A. I'm going to try to keep this color-coded. Sine of A times the cosine of B. And then we have minus, we keep the sign the same. So minus, we're going to have the sine of B times the cosine of A. All right. So now it's just going to be a matter of plugging everything. What is the sine of A? Well, we found the sine of A. That was 12/13. And 12/13 times the cosine of B. The cosine of B is 15/17. We have our minus sign. Sine of B is, yeah, see, I messed up my color coding. The sine of B is 8/17. And then the cosine, I need to fix that. Sorry, guys, that's going to bother me. All right, so we're going to have the sine of B, needs to be in blue, times the cosine of A. Angle A is red, angle B is blue. All right, so the sine of B is 8/17. And then cosine of A is -5. So this needs to be multiplied, so multiplied by -5/13. All right. Now it's just going to be a matter of throwing this all into your calculator. What does that give us? I don't know. I'm just going to throw it all in. If you want to make the fractions, great. So alpha y equals, press enter. You're going to have 12/13. All right, then you have times, make another fraction. You have 15/17. You have your minus sign, not a negative, but a minus sign. All right. Another fraction, so alpha y equals again. You're going to be pressing those buttons quite a few times here. Over 17. And then one more. Now it's a negative sign, all right? So make sure your calculator doesn't know the difference between a minus sign and a negative sign. So we do have two different buttons there. All right. So what does that give us? 220 or 221. Let's try that again. Equals 220 over 221. All right. And there we have it. Now the next one, the cosine of A minus B. Let's just look at that identity. Cosine of A minus B. Notice how on this thing, it goes plus minus and then minus plus. What that means is you have to do the opposite sign. So this one, it was the cosine of A minus B. So that means since it was a minus sign, that one will be a plus. All right, that's not a typo. That minus plus versus plus minus, that does mean something. This is just the opposite sign here. So what we're going to have is we have the cosine of A times the cosine. Let's see, I already forgot. Cosine of A times cosine of B, right? So cosine of A is -5/13. Here, let me just write it all out. We get cosine of A times the cosine of B. Right, we need to flip the sign. So plus the sine of A times the sine of B. Right now, let's punch it all in. Cosine of A is -5/13. Cosine of B, which I spelled wrong and did the wrong color for. Cosine of A times the cosine of B. The cosine of B is 15/17. Then we need the sine of A. And then the sine of B. All right, so this will be plus sine of A is 12/13. And then the sine of B is 18/17. All right. And again, throw it all in the calculator. So I'm going to do it differently this time. I'm just going to use divides. Division and fractions are the same thing. So times 15/17 plus, let's see here, we have 12/13 times 8/17. All right, this is good. The way I type it in my calculator now is going to give me a decimal. All right, we can fix that though. Just do math. enter, enter, and it'll turn it into a fraction. So there's your 21 over 221. And the last one, the tangent of A plus B. All right. This one is a little bit more ugly, but that's okay. Tangent of A plus B here. Keep in mind, look at the plus or minus here, plus or minus on top. So you keep the sign the same on the top, but on the bottom, it's the opposite, right? So we know, I'm going to write this one over here. Tangent of A plus B gives us, what do we have? Tangent of A. Half this video is me writing these formulas. Tangent of A plus the tangent of B over. Then we have 1 minus. This is where we take the opposite one. We have the tangent of A minus times. I can get my letter in here. The tangent of A times the tangent of B. All right. So let's plug all of that in here. So we have 12 over -5 on top plus 8/15. All right, so there's all the numerators. So we do have a fraction inside of a fraction here. So when we type this into our calculator, we do have to be a little extra careful here. So we have 12 over -5 times 8/15. Those two things are being multiplied together. So plugging all of that in, let's see what we get. I am going to make a fraction here. So alpha y equals, all right, so on the top, we're going to have 12 divided by 5, and then plus 8 divided by 15. All right, so there's your top. And then 1 minus, we're going to have 12 divided by -5 here, times 8 divided by 15. Might be a decimal, might be, all right, so it is a decimal. So let's just change it to a fraction. We're going to have 220 over 171. Right. And there we have it. Yeah, there we go. That's how we find them kind of off the unit circle. This next one is going to be on the unit circle. So what we have to do is 75, not on the unit circle here. Let's pull that up, not on the unit circle. So what we have to do is we have to think, all right, what two numbers, when we add them together, will give us 75. All right, so if we want to think about this one, the sign of 30 plus 75, how about 45? The sign of 30 plus 45. All right, those two numbers are in fact on the unit circle. All right, so expand it out. We know the identity up top here, right? The sign of A minus B. So this one's going to be a plus this time. Sine of A, cosine of B, plus sine of B, cosine of A. So if you want to think about it, here, let's do this. I'm going to color code these because of course I am. Let's call this a 30. And let's call this one a 45. So what we're going to have is, according to our identity, one more time, let me just pull it up. It's the plus sign, right? So sine, cosine, cosine. All right. So sine of A times the cosine of B here. And again, I'm going to use this one as my A, this one as my B. All right. So what we're going to have here is the sine of 30 times the sine of 45. Right? Plus and then switch them. So we're going to have the, should be a cosine. All right. Now the next one has to be the sine of 45 times the cosine of 30 now. All right. So all four of these things are on the unit circle. So the sine of 30, the unit circle right here, sine of 30 is 1/2. And so we have 1/2, right, times the cosine of 45. That's the square root of 2 over 2 plus the sine of 45 again is also square root of 2 over 2. See, and I messed up my color. You know, sorry, I don't even care anymore. Colors are off. Deal with it. The cosine of 30 square root of 3 over 2. All right. So let's just simplify this. We have the square root of 2 square root of 2 over 4 plus the square root of 6 over 4. Now, those are common denominators, so let's just call it square root of 2 plus square root of 6 all over 4. So that one's done. That is the exact value. When they say exact value, they mean no decimals. All right. So that's kind of what they're going for. Now the next one, the tangent of 105. They're saying this one's tough. So let's see what we can come up with here. Let's call this the tangent of, let's say, how about a 60-degree angle plus a 45-degree angle. All right, that'll get us what we need. All right, so I'm going to abandon the color coding. It's taking too long. So we know, according to this one, the sum and difference formula, we're going to have the tangent of 60 plus the tangent of 45. Right? All over 1 minus, right? That's where we get that opposite sign, the tangent of 60 times the tangent of 45. Right? So let's just grab all of those numbers. The tangent of 60 degrees is square root of 3. Right? Plus the tangent of 45. I think it's just 1. Yeah. All over 1 minus tangent of 60. That's a square root of 3. And then tangent of 45 is 1. All right. So that in and of itself, not too difficult. All right. If I simplify this a little bit, we have square root of 3 plus 1 all over 1 minus the square root of 3. All right. That's not so bad. However, they want it rationalized, and that's where it gets bad. So let's see what we can do here. I'm going to rewrite this down here. I'm going to need the room. Square root of 3 plus 1 over 1 minus the square root of 3. That in and of itself is not rationalized because the bottom, the denominator, has that radical there. We need to get that radical out. Square root of 3, no good. We got to move it up top. So we need to multiply by the conjugate. Anytime you have a binomial on the bottom with a radical, you need to think of conjugates here. So what is a conjugate? So the conjugate of a minus b is a plus b. These are what we call conjugates. All right, so it's going to be the same exact numbers. It's just the sign in the middle is different. So the conjugate of 1 minus square root of 3 is 1 plus the square root of 3. And we need to multiply that on the top and on the bottom. And now from here, we have to double distribute everything, right? So we're going to FOIL the top, we're going to FOIL the bottom, or double distribute it. So let's see what we get here. This is where we do this thing. Square root of 3 goes to everything. The 1 goes to everything. So we end up with square root of 3 times 1, square root of 3, and then we have plus a 3, then we have plus 1, and then plus another square root of 3. right? So there's your top. Now on the bottom, 1 times 1 is 1. Right? 1 times square root of 3, so that's plus the square root of 3. And now the next one, negative square root of 3 times 1 minus square root of 3. Right? And then negative square root of 3 times positive square root of 3. It's minus a normal 3. Right? So if you're looking at it and you're thinking that looks so much worse, kind of, but not really, because on the top we have like terms. You have 4 plus 2 square root of 3. Right? Those combine your like terms. And then on the bottom, look at this. Look at that. You have a positive square root of 3, negative square root of 3. They cancel each other out, and you're left with 1 minus 3. Well, 1 minus 3 is just negative 2. So we have 4 plus 2 radical 3 all over negative 2, right? So that looks a lot better. And then look at the top and the bottom. You can divide both of these things, right, by 2. So this ends up being, I'm going to move the negative. No, I'm not. I'm just going to do this. I'm going to say 2 plus 2 square root of 3 all over a negative 1. And I don't like that negative 1 there. So now I'm going to move it up top. We have negative 2 minus 2 square root of 3. And that is your final answer. Right? So if I plug in on here tangent of 105 into my calculator and making sure I'm in degree mode, because this is a degree, let's see what we get. All right, so the tangent of 105 can be some decimal. All right, negative 3.73. If I plug in this number, this negative 2 minus 2 square root of 3, if I did everything correctly, if I didn't make any algebra mistakes, it should be the same decimal, right? Which it's not. So that means I made a mistake somewhere. Awesome. I see it. All right. This 2 right here, that needs to go away. All right. Take 2. Here we go. I'm not going to edit that one out, so you're seeing my mistakes. It happens. But we found it, we fixed it, and that should be the same number, which it is. That negative 3.732 is what we got. All right, so we are good. I have 20 more minutes. Do I want to do this? Half angles. What they want us to do here? Find the exact values. Those half angles do get a little messy. The double angles get a little messy. So I'm going to end this video here. We're going to do this one later. All right, so see you guys in the next video.